So here is an explanation about how to compute the normal distribution probabilities and how to use the standard normal probability distribution tables. So we recall that the standard normal distribution is a distribution with a mean which is equal to 0 and standard deviation equals 1, and we call it the z distribution. Each time we need to find the z value in order to use the standard normal distribution table. If x is a random variable following a normal distribution with mean mu and standard deviation sigma, with this change of variable which is z equals x minus mu over sigma, z will follow the standard normal distribution, means it's a normal distribution with mean equals 0 and standard deviation equals 1. So here what's happening? Here we have two cases, two normal distributions which are in orange and color with different means and different standard deviation. So using the z transform x minus mu over sigma, we get the green curve which is the standard normal distribution. As you see, the mean here equals 0 and the standard deviation equals sigma. Now how we use the table of the standard normal distribution? Suppose we have the question, we want to find the probability of z when it is between 0 and 0.34. For this end, we need the table of the standard normal distribution z, which we have used in class and which gives the probability when z is between 0 and a positive value. So here are the steps. In order to find this probability, first find the row with the z-score 0.3. Next, look under the column 0.04. Then find where the row and the column intersect. It should meet in the needed result, which is here 0.1331. In fact, in literature we can find many tables of standard normal distribution. So the one which we have used in class is the table giving the probability under the area subtended by the curve 0 and the value of z. But in literature we can find other tables, like tables giving the whole area subtended by the curve beginning from minus infinity to the positive value that we have. Also, you can find tables giving the area which is after the positive value, as we can find some tables giving the area subtended by the curve and any negative value on the left side of the curve. Since in our course we used the first table, so let's focus on it. So the first table, in fact, it gives the probabilities between 0 and a value of z, like here in this case, which is 1.5. And as you know, 1.5 could be written as 1.50. So when we need to find this area which is subtended by the curve and the value of z and the value 1.5, we need to find the intersection between the row containing 1.5 and the column containing 0.00. So here the value of this probability is 0.4332. Now, how to apply standard normal distribution? So in fact, we have two steps as we saw before. So the first step, you have to standardize first the value of x and transform it to z value. Then use the z value and the standard normal distribution table to find the probability. Let's begin by this example. Suppose the weekly income of Uber drivers follows the normal probability distribution with a mean of $1,000 and standard deviation of 100. The question here is, what is the z value of income for a driver who earns 1,100 per week? And also we need to find the z value for a driver who earns $900 per week. So for the first question, we just have to apply the rule that the value of z will be 1,100 minus 1,000, which is the mean, over the standard deviation. So the corresponding z value for the value of x, $1,100, is 1. Applying the same rule for the second question, we find that the z value equals -1. So it's 900 minus 1000 over 100. Now, for the second question, we will use the table of the standard normal distribution. So the question is, what is the likelihood of selecting a driver whose weekly income is between 1000 and 1100? First of all, you have to write the question in a math way. So here we need to find the probability that the value of x is between 1000 and 1100. So this leads to this graph. So in fact, if we have a normal distribution with a mean of 1000, this is the situation. We need to find the area subtended by the curve and the two values 1000 and 1100 shaded here in gray. Then you have to make your transformation. So you have to standardize the random variable x and transform it to z. So as we saw in the first question, z equals x minus 1000 over 100. Now the question is, if x is between 1000 and 1100, what will be the boundaries of z? To answer this question, we need to start from the inequality in x. So we begin by writing that x is between 1000 and 1100. Now to transform x into z, we need first to subtract 1000. So we get that x minus 1000 is between 0 and 100. Then we need to divide by 100. So the value of z will be between 0 and 1. Which means that using the standard normal distribution, we need to find the area of the standard normal curve subtended by the curve and the value of 0 and 1. Which means that the probability of x is between 1000 and 1100 is the same thing as the probability of z between 0 and 1. Now using the standard normal distribution table, all what we need is to find the intersection of the row containing the value of 1 and the column containing 0.00. And as you see here, the value is 0.3413. Question number 3 asks about the probability of selecting a driver whose income is between $790 and $1,000. So we keep the same method. So we begin by writing the question in math way. Graphically, we must understand that we need this area which is shaded in gray between $790 and 1000. Then we make our transformation. We standardize the random variable x into z. Then we start from the inequality in x. Now to transform x into z, we first subtract the value of 1000. So, which means that minus 210 is less than x minus 1000 less than 0. Then we divide by the standard deviation and we get that the value of z will be between minus 2.10 and 0. Hence, the probability of x between 790 and 1000 is the same as the probability of z being between minus 2.10 and 0. And this leads to this graph which shows the same area as the graph before. Now, since minus 2.10 is a negative value and we have a table showing only the probabilities for positive values, we need to express this probability in terms of positive values. Instead of minus 2.10, I need to find an expression of this probability using the value of 2.10. Fortunately, we can see that this graph or this area is the same as the area between 0 and 2.10. So we can write that this probability is the same as the probability of z between 0 and 2.10. Now we could use the standard normal distribution table. The intersection of the row containing 2.1 and the column containing 0.00 is in the value of 0.421, which is the final result for this question. In question 4, we are asking about the probability of selecting a driver whose income is less than 790. So, as usual, we begin by writing this question in math way. This means that we need to find the area subtended by the graph and which is before the value of 790, which is the small area here in gray. Now, As usual, we start from the inequality in x. We should transform it in a z inequality. So we subtract 1000, then we divide both sides by the standard deviation, which is minus 2.10. So this area is the same as the area where z is less than minus 2.10. We've got here a negative value which is minus 2.10, and in order to use the table, we need to transform this value in a positive value. We remark that the area on the left side of minus 2.1 is the same as the area on the right side of 2.1. So we could write that this probability equals to the probability of z greater than 2.10. But still here we have one problem, is that the table of the standard normal distribution gives the probability between 0 and the positive value. Using the fact that half of the area of the normal curve equals 0.5, we can deduce that this probability is the same as 0.5 minus the probability of z between 0 and 2.10. Now we can use the standard normal distribution table or the previous question to see that this is equal to 0.5 minus 0.481. So the final result is 0.0179. Question number 5. What is the probability of selecting an Uber driver whose income between $840 and $1,200? So writing the question in math way, so we need here to find the probability that x is between 840 and 1,200. Graphically, this means that we need to find this area which is shaded in gray. As in the previous question, we start from the inequality in x, and we should transform this inequality in terms of z. So we subtract 1000, which is the mean, then we divide this inequality by 100. So we get z is between the values of minus 1.6 and 2. So graphically it means that we need to find the area subtended by the standard normal distribution and the value of minus 1.6 and the value of 2. So in order to find this probability, we can think about splitting this area in two parts. The first part is between minus 1.6 and 0, and the second part is between 0 and 2, which means that the probability between our hands is the same as the probability of z between minus 1.6 and 0 plus the probability of z between 0 and 2. For the first graph, we remark that the shaded area is the same area between subtended by the curve and the values 0 and 1.6. And for the second graph, we keep it as it is. So in terms of equation, this means that we need to find the probability of z between 0 and 1.6 and the probability of z between 0 and 2. Now we can use the standard normal distribution table and we get the result. And the last question, we need to find the probability of selecting a driver whose income is between $1,150 and $1,250. So here are the steps. We write the question in math way. In this case, we need to find the area on the right side of the graph, subtended by the values 1,150 and 1,250. Starting from the inequality in x, we subtract the mean to get 150 on the left side and 250 on the right side. Then we divide the whole inequality by 100, that the value of z will be between 1.5 and 2.5. So which means that the probability of x being between 1,150 and 1,250 is the same probability when z is between 1.5 and 2.5. So graphically, using the standard normal distribution graph, we get this situation. Once again, we need to analyze this situation in order to use the standard normal distribution table. We can think about writing this area as the difference between the following two areas. The first area is between 0 and 2.5 and the second between 0 and 1.5. So in math way, we can write this as the probability of z between 0 and 2.5 minus the probability of z between 0 and 1.5. Using the standard normal distribution table, we can find these values and the final result is 0.0606.